Hey again, guys, and welcome back. Today I want to talk to you about one of the most important parts of my channel that never really got a spotlight. This here is the module I use to power the majority of my projects, actually. This is a Minghe D3806. If you search D3806 on your favorite Chinese reseller, eBay, even Amazon and AliExpress, you'll be able to find this thing. I think Banggood has it as well. I'm not sure. If it does, I'll put an affiliate link in the description. This is a power supply with adjustable voltage, which is very important if you're doing electronics, and adjustable current, which is, some would say, more important. I would say, throw caution to the wind, and it's a little bit less important. But either way, it's really good to have. It is also a boost buck. So whatever you put on the input, you can go below that or above that or exactly the same voltage, which is amazing. So generally speaking, I will be powering it off this power brick that I got from a thrift store. And if I can pull my cables here. So it just terminates in a little power jack here. The DC in jack, just plug it into there. And this is a 12 volt 4 amp unit. Now the thing with these converters is you can't get more wattage, more power out than what you put in. So this is 12 volts 4 amps. I can certainly power something that's 24 volts, but the maximum then would be 2 amps, right? Because you're doubling the voltage, halving the current. So this thing is great for most things, but not for everything. Aside from that, I have a 24 volt power supply, and I think it's a 24 volt 10 amp power supply, sort of up that way. But I don't really use that for, low current things, low power things. I just use it if I need more juice to, say, charge batteries or whatever. So this guy here has two input functions. It has the jack here, which I use most of the time. When I use the 24 volt power supply, I'll use these terminals here. So it actually is broken out into terminals. The build quality is okay. It's nothing really to write home about. They do have solder on all the tracks on the back for a little bit more current handling capability. But all these components are kind of loosey. I think I would probably put some hot glue on them in the future. I don't know. It does have a current shunt here. This is a I think that is a 20 millivolt or 20 milliohm resistor, and so it does calculate the output current. It's reasonably accurate, but it's not that great. It has a fan header, which I believe just gives you a constant 12 volts to the fan, which is pretty good. It also has this control board here is actually on a daughter board. It's soldered in quite well, so I really don't want to pull it out because I have issues putting it back in. But if you did want to remote mount this somewhere, you could do that. The output, however, is one of the downsides, one of the things I don't like, because it has these screw terminals, which is convenient for a lot of things, but for quick connections, it really isn't. So I actually have plans to mount this on a board or something and put a whole bunch of different output options on the side. Personally, I would like 2 banana jacks, so I'd like the binding posts, so that I can use 4mm bullets, or I can pinch a wire inside. I would also like some spring terminals, sort of like these guys. These kinds of spring terminals, because they're conducive to quick hookups. And probably also have a set of sort of these screw terminals like that. So that's something I'm going to add in the actually in the near future, I'll say, I'll probably build a case around this just to make it a little bit less susceptible, because another bad thing is all these connections here are exposed on the backside. So if my bench is full of clutter, which it never is, if I put this down on top of clutter and it's conductive, like this knife, I'll short something out. And because of the power input here, if you look, this is the input jacks right here. Bridging across this on a 400 watt power supply will probably just blow it up or blow a fuse or something. So I definitely want to put this in a case or something to protect it, and also give me more connection options at the same time. I might do that. Maybe I'll make this module a little bit taller and put this sort of up here somewhere and put a little fan in the back. We'll see. That's all up for debate. But right now, I wanted to show you guys this thing because I've been kind of neglecting it. So upon boot up, you get your voltage, your last voltage amount used, but only if you had pressed set. So like this is 13.5 volts. If I drop this down to, let's say 12 volts on the dot, and I just go OK, which turns on the output, when I turn this off like this, it will boot up to 13.5 volts still. There we go, 13.5. So what you have to do is when you set the voltage, if you want to save it like this, you just hit set, and now you can do your output. You can turn it off, you can turn up the voltage, give the output on, off, and then when you remove the power to the unit and power it back up, you'll get back your saved value. There's a few more functions that are built into this, like you can, for example, save different parameters to different memory slots, but I've never used that. I've never had to use that. It's kind of silly. If you want to use that, then there's a, if you just search D3806 manual, you'll see the actual manual for this thing. On top of that, when the output is on, you can use OK to scroll to your current reading. So that little dot there being in the first slot is your current reading. Then you've got your power reading, and then you've got your capacity reading. So your capacity will just measure in portions of amp hours. So this would be your milliamp hours here. How much current has flown, how much capacity has flown into, like, let's say a battery from here. And then if you press OK, it goes back to your voltage. So yeah, it works. This thing is great. If you're just looking for something to mess around with, this guy is enough power supply, but you need a AC to DC brick. So if you don't have a way to power this thing, which by the way, you could use a lead acid battery or something, for example. So if you do have some way to give it DC, I'd say do it. But that's just a quick look for today. This thing, you can find it in any one of my videos where I need a variable voltage and a current limit. I also put layers of tape on the LCD. So I put tape, colored it with red Sharpie, put tape over, colored it with red Sharpie, and I think I have 3 layers on there, and it makes the display a lot easier to see. It is easy to see without this, but not on camera. So I can see it quite clearly for me, but you guys see it much better with the red on it. You can buy special red tape for this, or red electrical tape, but I mean, I have Sharpies, I had tape, I gave it a shot, it worked. Also, this thing is relatively efficient. I don't get very much heat off these heat sinks, but I'll probably characterize this thing in another video. But right now, I just wanted to make sure that if you guys want to get one, you have the information you need to go buy one. So yeah, that's it for today. If there's any specific questions about this module, let me know in the comments below and I will try to answer them. If you're just looking for something to regulate voltage and current, I would say any buck boost with a CCCV function is perfect, but this guy here is a little bit higher current possibilities, so I like this. It goes up to 38 volts, by the way, and 6 amps. I don't think it can do 6 amps at 38 volts, but that's what the 3806 means. Alright, well, hopefully I'll catch you in the next video. Thanks for watching.